We have another example on the board. I'm going to start solving this problem from finding Z total. Now, please notice that we have given power factor and resistance. You have to remember the formula which says that power factor is equal R over Z total. So, in order to find Z total, I'm supposed to simply just rearrange this formula and solve this formula for Z total. So I have Z total equals R over power factor, where R is equal 110 ohms over power factor 0.87, which is equal 126.43 ohms. So this is the magnitude of my Z total. This is not full answer yet, because we have to find the angle. Remember, we have another formula for power factor, which says power factor is equal cosine of angle theta. In order to find angle theta, I'm supposed to simply write theta is equal inverse cosine of power factor. So this is equal inverse cosine of 0.87. This is equal 29.54 degrees. Now, please notice that we are going to have positive angle because we are dealing with the RL circuit. In the RL circuit, current is going to lag the voltage source by this angle. So that's why we are going to have always positive sign at the front of this value, okay? My angle must be positive. Next, I'm supposed to find Z total. We're supposed to write Z total with angle. So I have 126.43 ohms and angle of 29.54 degrees. Okay, so this is the full answer for my Z total. Next, we're supposed to find I total. I total, I'm going to find by using Ohm's law. I total is equal voltage source over Z total. Please notice that this is peak value. Okay, so current which I'm going to have over here is going to be also peak. So I have voltage source 100 volts and angle of 30 degrees divided by Z total, which is equal 126.43 ohms and angle of 29.54 degrees. So I have the value of my current equal 790.95 milliamps and angle of 0.46 degrees. Okay, so this is my current in the circuit. So this current is called I total. Don't forget that this is going to be peak value. So I can say that I total peak is equal to IR peak and is also equal to IC peak. Please notice that this current is lagging the voltage source by angle of 29.54 degrees. Next, we're supposed to find the impedance of the inductor. Please notice that this is a series circuit. So total impedance is equal resistance plus ZL. In order to find ZL, I'm supposed to use algebra, so I have ZL equals Z total minus R. I can do this calculation because Z total has angle. Okay, if you have angle, you can perform this subtraction. So I have Z total 126.43 ohms and angle of 29.54 degrees minus the resistance, which is equal 110 ohms, equals 62.33 ohms and angle of 90 degrees. So this is the value of ZL. Now we can find the inductance of the inductor. We have a formula which says ZL is equal omega L. In order to find L, I'm supposed to divide both sides of my formula by omega. So I have inductance is equal ZL over omega, where ZL we found is equal 62.33 ohms over omega, which is equal 2000 radians per second. This is equal 31.16 millihenries. This is the inductance of my inductor. True power we are going to find by using the formula P is equal 1/2 IR square times resistance. Why 1/2? Because I found before the peak current by dividing voltage peak by the total impedance. So I have 1/2 times the current IR, which is equal to 790.95 milliamps to the second power times the resistance 110 ohms is equal 34.4 watts. And this is the true power in my circuit. Next, we're supposed to find the reactive power. QL is equal 1/2 IL squared times ZL, which is equal 1/2 790.95 milliamps to the second power times ZL, which is equal 62.33 ohms. Okay, and this is equal 19.49 volt ampere reactive. Again, one more time, I'm using 1/2 because I'm using the peak current. Okay. So next, we're supposed to find the apparent power S, which is equal 1/2 I total square times Z total, which is equal 1/2 790.95 milliamps square times Z total, which is equal 126.43 ohms. This is equal 39.54 volt ampere. Next, we can draw the power triangle. So I have true power, P true is equal 34.4 watts, and I have QL, which is equal 19.49 volt ampere reactive, and I have apparent power S, which is equal 39.54 volt ampere, and this is my angle theta. So we can say that problem is solved.